Okay, I wanted to, before we start, I wanted to go through an email that basically says, I don't think any of the people that are in here right now this affects, but okay, so these are the people over here on the right. Whoops, I need to put it under the screen. These are the people that are affected by the discontinuation of the mechatronics bachelor's of science degree. Now, that will not happen until fall semester, so this is not going to happen immediately. But if there's anybody in here that is and I don't think there's anybody physically in this room right now, but yet I think Bulmer is and Fent is, and I hopefully they will hear this. And I think if they graduate right now, it'll be okay. But if they graduate next year, that may not be available to them. So again, that's neither here nor there for you guys. But it's a email to please check up with me if you have any questions or anybody has any questions about that. That concentration was not going anywhere. Some of the courses were not being able to be offered, and we just kind of wanted to clean things up. And that's the reason for that. Okay, so that gets us through that. Okay. And we'll forget about Tucker. Okay. So let's start working some of these problems. This is problem number one. And so we've got 12 volts. So we're just going to start down through some of these and 4 ohms and 2 henries. And find I of t. Well, I of t, let's convert to the S domain. Okay, so let's just turn to the S domain. Let's go with window, let's go to Lagoon, and let's go with a different color. Let's go with red. Okay, so it's 12 over S here. It's 4 here, and instead of the 2 henries, it's 2S. So we now have a process that we can use in the S domain. In the S domain, we can do this. So now let's see what would be I. I is equal to 12 over S V over 4 plus 2S. Now let's solve for I. So it's 12 over S times 1 over 2S plus 4. Everybody agree with that? All right. So let's cancel. Let's do some canceling. Let's do this 6 over S plus 2. So it's 6 over S times S plus 2. All right. Now that is my I in the S domain. I parenthesis S if you want to. I refuse to do that because why? I don't want to get S's mixed in, so I just use I. So now, what do you do here? We do separation of variables, right? It's equal to A over S plus B over S plus 2. So 6 over S times S plus 2 equal that. So how do you play the game? Let S equal 0, let S equal minus 2. We can solve for this. So it's equal to 6 is equal to A times S plus 2 plus B times S. So if we let S equal 0, out pops A times 2 equal to 6, A better equal to 3. Minus 2, this term drops out. 6 is equal to B times minus 2. B is equal to minus 3. Is that what everybody got? Everybody agree with that? Leo, do you feel like that's good to go? Okay, so now we can substitute this back in, use the formula that we've got, which is what? It's 3 minus 3e to the minus 2t, and we're done. Everybody agree? That's it. Easy peasy, right? Or it's 3 times 1 minus e to the minus t over tau, which is all over r. What is tau? Tau is L over R, or whatever, 1/2, but you flip it and it becomes 2. So that's it. It's exactly what it is. Any questions, any comments? Everybody see how this game is played? You only got 49 more to go. I'm going to say for your homework, do any 15, and you pick which 15 you want to do. For this one, I wanted you to hand in 2 for today. We might pick 2 down the road for next week or whatever. I don't know, but you now have a path. Okay, so I should have flipped back into the time domain and written this in, instead of in red, I've written it in black, but you got it. You got the idea. Okay, so let's do this again. Are these fun or what, huh? They're not fun, and they get harder, but basically they're this, you get the idea. So now we've got another one. This is a, okay, so here we've got 12 and we've got, what's the last one? What's the last one? Huh? Oh, and now I've got initial current. So yeah, I can, now I've got to play the game with the initial current, right? So here we go. So now we've got, 2, we've got 12, and we've got a 4 ohm up here, and we've got our same 2 Henry over here. But now I have an initial current of 2 amps. So I've got 2 amps going through this at t equals 0. So now what do? Well, I have to now rebuild this in the S domain as what? All right, let's go back and let's do the same thing again. Let's go down here. No, color. So it's 12 over S. This is 4, and this is LS, and then we also have to add in a little voltage supply here with a minus, plus on the bottom, minus on the top of L I of 0. It's a voltage supply. So now we've got what? So for Li of 0 is what? I of 0 is 2. So L times 2. That's another voltage supply. So now our question is, it's I is equal to 12 plus 2L over, that's our V, over our R. Okay, so our R is 4. This is LS. Plus 2S. Okay, is that right? Have everybody got? Anybody not get? Did anybody not get that? Is that what you got? Here's the voltage with a plus down. Okay, so the voltage is L times I at 0, or L times 2. Okay, Now I have the answers as well for these. So if we want to go back and look at the answers, let's just see what our answer for this one is. This is cheating 101, but let's just see what the answers for this one are. So the answer for number 2. Oh, I don't have the answers. Daggone it. I lost a few of them at the beginning. But this is the way you work this. This is how this is done. Okay, so 2 times L is 4. So this is 2 times 2. So it's 12 plus 4. Or 16 over 4 plus. I did that wrong. Forget about that. Let's start it. Let's just start again, please. Let's start again. Or no, I can go back and erase that. Not having worked all these ahead of time, it is a little bit of interest to me. I wanted to get through some of this, but I just said to heck with it as far as working through them all. But we can work through these. We can do that. Okay, so let's go back up here. Color is still red. Okay, so the answer to I, whoops, I don't want to get that. I want to get I is equal to voltage, which is 12 over S, plus L, which is 2 times 2, so L over S plus 4, all that over what? My resistance, which is 4 plus LS, or 2 plus 2S. All right, so now I've got to combine this with this. So it now is 4S over S. So it's 4S plus 12 over S times 2S plus 4, okay? Now there's a big canceling that's going to go on here, so the 2 and the 4 go away. This is 2S plus 6, so it's equal to 2S plus 6 over S times S plus 2. Now we do our A and a B. Okay, so it's equal to 2S plus 6 is equal to A over S plus B over S plus 2. And there's a S times S plus 2 over here. So it's equal to, okay, so it's equal to A times S plus 2 plus B times S. So 2S plus 6 is now equal to this. Okay, so with that in mind, let A equals 0, let A equals minus 2, let S equal 0, let S equal minus 2. So here we have 2S plus 6 equals A times S plus 2 plus B times S. If S equals 0, we have 6 is equal to A times 2, or A equals 3, which is the same. Okay, equals minus 2. Minus 2 is so this is equal to is equal to 6 minus 4, or 2 is equal to B times minus 2. B is equal to minus 1. So this one is a little different in that what? Our final answer is, I'm going to go back to the color of black. Okay, so our final answer is what? I of t, or I of t. is equal to 3, which is this term, minus 1 e to the minus 2t. Everybody see that? Okay, so that's number 2. We're gonna get tired of working these after a while, but I honestly, if you go through these enough and you get tired, so be it. I want you to get as many of these so you understand this stuff with your eyes closed, so you can do these without batting an eye. You can do these. That's the goal of this. Okay. So number 3, is everybody ready for number 3? Was Now the battery is removed here, and you have initial conditions, but there is no voltage. So this one is where you basically this goes away. So let's just this one is the e to the minus t over tau. So that's all this one is. So basically this one is number 3. The battery goes away, and you've got 5 ohms, and you've got 1 Henry. You've got an initial condition here of what? Initial condition of 5 amps at t equals 0. Okay, so that's all you have. Now, how do you do this one? Same way as you did the other ones, but without the V of S. So basically it's I is equal to what? V, which is this guy, which is, well, I can go back to red. I is equal to, in this S domain, V, which is nothing more now than, it's going this way, L, which is 1 times I, which I at 0, which is 5, that's all it is, over what? The R, which is 5 plus 1S, and that's all it is. So now we have, all we have is 5 over 5 plus S. How do you solve this one? This one you can go straight to the rule number 2. You don't have to do separation of variables. You can say it's 5, S A equals minus 2, or A equals minus 5. It's 5e to the minus 5t. Everybody follow that? Is everybody with me there as far as doing these? Can you now start seeing how these are done? It's like, this is all this is. I got 50 of them. All right? So that's all you got to do. Okay, now here's another one. Here we change this. We really don't change it. It's the same problem that we had before. It's 10 is 10 over S, right? So this is the same as problem number 1. Okay. Somebody tell me how to work this one. Oops. Well, tell me how to do this one. This is number 4. Go through the steps. And just tell me the whole thing. Lead me through it. Okay, so I want I. All you guys, all you now. Yes, sir. Ready? Go. Very good. Right? Or just S, yeah. All right. So let's go to red so that we can do the rest of it. Okay, equals what? Right? Okay, so what's the split here? S is in the denominator. This is in the denominator. This is in the denominator. You can split these apart. This is the numerator, the denominator is the denominator. The denominator of the denominator is the numerator. Okay? Everybody say that. The numerator of the denominator is the denominator. The denominator of the denominator is the numerator. So if it's the bottom of this, it flips to the top. Okay, so this comes over here. This goes over there. Now what? Does everybody agree with that? The denominator of the denominator is the numerator. The numerator of the denominator is the denominator. Okay? Just say that about 20 times and you'll get it. Because you got to do that here. All right? So what does this equal? How do you solve this? Yeah, you got it to this point, but now I want to go ahead and solve it. How do you solve it? Okay? Do that much. Okay, now what? Let what? Tired of doing this, but that's exactly what you do. Now what is A? A is 5, right? What is B? 10 equal minus 2, so minus 5. Is that right? So now you go back to the time domain. I of t, you can write small letter I of t is equal to what? 5 minus 5e to the minus 2t, and you're done. Piece of cake, right? They get harder, but they never get that hard, okay? Now you got the pattern. That's the pattern for this. Now, what is this one? Again, oh, what is this? This is just this is the same as this one. They're the same thing. I'm not going to worry about this one. You can do this one yourself, okay? This one is a what? Number 6. What is number 6? What is my input? What is 5 delta? What is delta? It's a spike, isn't it? Okay, so boop, and then done. Okay, so what is the conversion of that? Well, the only hint that you have is rule number 26 on your sheet. But the rule for this is it's equal to basically whatever that number is there. So basically, for a Dirac delta, it's just 5. So the conversion for that is just a 5. Okay, so we got 1 up here, we've got 1 over here, and then we got 5 over there. So let's do our conversion in. So the conversion of that is just a 5. And this is a 1, and this is a what? What's the conversion for that? one S or just S. Okay, 1 times S or just S. So what is our value now? I is equal to 5 divided by 1 plus S, or S plus 1. Can you figure that one out? But the answer is just, this is easy. I of t is equal to 5e to the minus t. That's all it is. So if you put a pulse in, what you get out is a down. It starts high and it comes down like that. That's all it does. So you basically load it, and then it just dies away. That's all it is. Which is what you'd expect. If you put a pulse into something, if you put a really high value in, what does the output of that look like? It looks like it just dies away. And that's exactly what you'll get. Okay? But you see the math for how to do it? That's all it is. So the 5 delta is just a 5. If it's just a number, u to the something, it's that number over s. You got to remember the over s. If you see the delta, all of a sudden you got to say, okay. What's the other one? What are the variables that I gave you as far as these concerned? I did not give you an e to the minus t. They had those in there, and I didn't do them. What are the 3 inputs that I can give you? U of t, the delta of t. What's the other one? T. All right? So what is this one? It's just a step. What is this one? It's a blip. What is this one? It's a ramp. Okay? And you can have any of those 3 as inputs. Okay. So anyway, those are your 3 input types. Okay. There's the Dirac delta. What's this one? This is the other one, the other brother. This is the T. So what's the conversion of the T? What is the conversion of the T? So look at rule 1. The conversion of a constant is 1 over s. Rule 3 is with the t, it's 1 over s squared. Okay? Everybody understand that? If t to the 1 is your variable, n is 1, and the conversion of that is 1 over s to the n plus 1 or 2. So it's s squared. So you got to remember is the Dirac delta is just straight, like 5 delta is just 5. 5u to the t is equal to what? 5 over s. And 5t is equal to 5 over s squared. That's all you got to remember. I promise you, it will not get any worse than that. Does everybody understand that conversion? So you can write those on your sheet, and you're capable of doing. That's all you got to do. This test is going to be 10 questions like these. That's all it's going to be. I'm just going to randomly pick them, change the numbers around, and that's all it's going to be. But you got to be able to do these. You got to be able to respond. Okay, this is a t, this is the delta, this is the whatever. But that's all it is. All right. So now, with that in mind, how do you convert this guy? All right. So this is number 7. 10t, 5, and 1. And what do you? Okay, now I'm going to convert this over to the S domain. So what's the conversion of this one? 10 over s squared. What's the conversion of that? 5. What's the conversion of that? Well, I didn't even write it down. It's 1, so it's 1s. Okay? Everybody agree with that? Piece of cake, right? So what do you write for I? I is equal to 10 over s squared over 5 plus s, which is equal to 10 over s squared times 1 over s plus 5. Okay, now, what's the split? Wilmer, what's the split?
Uh, would it be 10 equals, and
No, I want to write A, B, and C. I want to do the split. I want to separate this out into this separate. I want to do separation of variables. What's the splits?
then A over S, A over B over S squared, and C over S plus 1
Say it again now. A over S plus B over what?
would be S squared,
Yes.
and then C over S plus 1.
Very good. Okay, very good. Now, this is one that you have to do you can't just automatically knock out A, B, and C. Why? You can knock out which one? You can knock out the B and you can knock out the C, but you cannot knock out no, you can knock out, well, let's just see what you can knock out and what you can't knock out. Okay, let's try this, see what we got. So, it's 10 is equal to A times S plus 5 plus B times S plus 5 plus C times S squared. Does everybody agree with that? Let, I'll give you S equals 0. Let, what else can you do? S equals minus 5. So if you do the S equals 0, what happens? You get B, right? 10 is equal to S times 5, F times B times, bless you, times 5, B is equal to 2. Everybody got that? So now you got B. Now, what about this term and this term going away? And then you've got 10 is equal to 5 to C times S squared, or 25, okay? C is equal to 10 over 25, or what? 2/5, okay? Everybody agree with that? But you still don't have A, or you still don't have A, right? So what are you going to have to do here? What's your last move? Do the balancing act. On the left, we have a 10. On the right, we have an A times S squared plus 5S plus B times S plus 5 plus C S squared. Now you pick one to your advantage, okay? You notice the S squared terms. A plus C equals 10. A plus C is equal to 10, or you can say the B term is okay as well. No, excuse me, no, I'm sorry. No, it's not equal to 10. A plus C is equal to 0 because there's no S squared term on the left-hand side, Ted. S squared, there is 0 on the left-hand side, is equal to A plus C. Everybody see that? That's the way you do it, exactly. S squared term, there's none on the left, there's an A, and there's a C. So if C is equal to 2/5, A is equal to what? Minus 2/5, and you're done. All right, everybody understand that move? You could have done it with the S term as well if you wanted to, or you could have done it with the no, you couldn't. You could have done it with the a number of ways, but this way works. You could have done the balancing act with the s to the 1 term, and you could have done it with the s to the 0 term, and any of the three would have worked. Okay, enough on that. So now what do? We go back and we rewrite this, right? What do we say? What's our final answer? I of t is equal to, the a term is equal to minus 2/5, minus 2/5. The b term is s squared, which is what? B term is plus 2t, and the c term is what? Plus 2/5 e to the minus 5t. Any questions about that? Are you saying, when are we ever going to get through this and be done with this and be out of here? Is that what you're thinking now? We're 7/50ths of the way through this. I got 50 of them. If you can do these, you're home free, okay? Now, there's more to doing these than just for me for this test. Okay, this is a test that's coming up. You all know that. You all know what's going to happen. But what is this about? This is the base way of finding anything. Okay? This will be on the PE test. I guarantee you. If you can do these, you can do the PE test. And it does give you understanding, like I said, about the stuff that you can see that you probably couldn't have seen otherwise. Oh, this is the way to do it. Yeah, I can see it now. Okay, so you can figure out any question having to do with L's, R's, and C's, with any type of voltage supply. And that's basically all this is. But this gives you an in to be able to solve questions. Sorry about that. So this gives you an in, basically, okay? So now, same song, second verse, right? No, this is not, this is a new one. Nope, this is the same thing we did before, so I'm gonna go by that one. Okay, now we're down to a little different. We're down to a little different here in that we're now down to a capacitor. So we've got 10 U of t, or just 10. We've got up here, we've got 5. Over here, we've got 0.2. One of the reasons I did this is because the stuff in the book was 0.2 times 10 to the minus 6. This is really bad in a hurry. Okay, so this is all this is. Now, what do? Well, this is 10 over S. This is 5. And what is the capacitor? 5 over S. It's 0.2 in the denominator, 1 over C. So 1 over 0.2 is 5. So it's 5 over S. So what is I? 10 over S over 5 plus 5 over S. Now it's 5S. Okay, so it's 5S plus 5 over S. The denominators go away. What? 10 over 5S plus 5, or what? 2 over S plus 1. Bingo. What's that? What is that? I of t is what? Two e to the minus t. That's all it is. Yeah, that's all it is. So but once you found this, you can find everything else in a circuit. You can find the voltage across, what's the voltage across the 5 ohm resistor? Okay, once you found this I of t, what is the voltage across this? It's that times that. And then what is this? It's what's left over the 10 minus the voltage across that is the voltage across that. And you can find everything else. So if you find this, everything else falls out. Okay? Another way to work the other one that you can ask for, what is the voltage across the capacitor? It's voltage divider. We're gonna get into worse ones. This is just we're just starting. We're just getting started out, but everybody should be able to do this by now. Okay. Again, initial charge on the capacitor. Number 10. And I'm not doing these for my health. I'm doing them so that you can look at them and you can work at them and you can work them as well. And you should be able to work these without looking at the answer and then look at the answer and say, okay, now I can do these and go all the way through and do them. Because I'm not going to do anything any harder than any of these. I might ask you a little bit different, some of them. I mean, in that last one, I could have asked you what's the voltage across the resistor or the voltage across the capacitor. But once you found the I of t, you basically can get the rest of it pretty straightforward. Okay, so this is number 10. We've got 20 over here. I've got 10 up here. And I've got 0.5 over here. And I've got an initial capacitive voltage of 4 volts. So I've got a plus 4 minus to start with. So what do you do there? Well, you basically say 20 over S down here, 10 up there, and this would be what? 2 over S, and then I have a voltage supply here of plus to minus of 4 over S. So what is my voltage around this loop? So my I is equal to this minus this, because this is plus and this is minus. So as you go around this loop, it's 20 over S minus 4 over S, or what? Well, let's write it as 20 over S minus, excuse me, no, it's plus, it's a plus 4, no, it's a minus, Ted. You go around the loop, this is plus, this is minus, so it's minus 4 over S, okay? So it's 16 over S. Over what? 10 plus 2 over S, right? So now we have 20 minus 4, or 16. I should just have written 16. (16 over S times 10). Whoops. Bless you. Bless you. One over 10S plus 2 over. Huh? No, it doesn't. Yeah, this is a 10 up there. Over 10S plus.
Because you combine the 10 plus 2 over S on the bottom. So you get a times 10 by S over S.
Yes. Okay, so yeah, and then that S goes to the numerator, so that these S's cancel out. So this is 16 over 10s plus 2. So now we get 8 over 5s plus 1. Or you got to get this, you got to get the s there. Now it gets a little messy. So you have to basically say s plus 1 over 5. You have to extract the 5 times s plus. Okay, so that's what you do there. Okay, so 8/5. Is that right? I think so. I think that's right. Anyway, so what's your final answer? Back in the black. I of t, 8/5, e to the minus 0.2t. Okay, any questions about number 10? This is another one with the same basic problem, except for the fact that now you've taken out the 20 over s. Okay, so that's all you've got now is the initial value of 10 volts. So I have here the current going the opposite way. It's the same problem, except for now there is no current on there's no voltage supply on the. So with this one, all I got to do is this is 5, and this is 2 over s for my value, for my resistance, but my battery here is initial voltage of 10. So it's a plus to minus 10 over s. So my I is equal to the, if I'm going in this direction, is equal to the minus 10 over s over 5 plus 2 over s. And again, I won't work this one out, but this is going to be a e to the minus whatever, all it is. Number 12, same thing, okay? 13, this is a little different. This is number 13, a little different. So number 13 is a delta. So number 13, we have a 5 delta, which is a spike, 5 times that spike. And then we've got a value up here, and we've got a capacitance down here, and we go with 5. This is not 5 over s anymore, it's just 5. This is 5 up here, and this is 1 over s. What could be simpler, right? I of s is equal to 5 divided by 5 plus 1 over s. Is that right? Huh? Oh, that's okay, you're right. Good eye. This is a 1. So it's equal to 5 divided by 1 plus 1 over s, or 5 over s plus 1. There's a 5s in the numerator, right? S plus 1. Now, what do you do with this? Is there such a thing? Do you find anything on your sheet that does that, that says that? The answer is no. Okay, so what do? You have to revert to old style long division. Okay, so it's 5s divided by s plus 1. S into 5s gives me what? 5. 5s is equals, okay, and then what do you have 0 plus 1. So it's equal to 5. So my answer is 5 plus what? 5s plus, this is 5 times s plus 5. So minus 5. Okay, this is this minus this, right? It's just this 5s. Let me do this right. It's been a long time since I've done this, but this is how you do it. You divide 5s, which is the numerator, divided by the denominator. So it's 5s plus 1. So it's 5 there, so it's 5s. Yeah, so it's 5s plus 5. And then minus this, plus 0 up here, right? 0 minus a 5 is a minus 5. So it's a minus 5, Ted, over s plus 1. So what do you do to convert the 5? What is this converted to? I of t is equal to what? 5 delta. You work it the other way. You work it backwards. Minus 5 e to the minus t. Okay? Any questions about how that's done? So when you get when you get an s in the numerator and an s in the denominator, what do? You got to revert to this. It's kind of hard on a Monday morning in March to accept all this stuff, but that's what you got to do. Everybody understand that? Everybody got that? Kind of? Maybe? And it's kind of what you would expect because that's what you started out with. So you get it coming back at you. Okay, but that's how it's done. That's the math part of it, okay? That's number 13. 14. Oh my goodness. He did it the other way. Okay, so what are we doing now? Number 14. So now we've got 10t. 2.5 microfarads. Okay, so I want I. What is I? Somebody tell me. Fent? Hello? What do you think? What's I? Give me the formula for I. It's V over R. What's V? What's the conversion of this?
10 over s squared.
Very good. So it's V over R. What's R? I'll give you the 2. Max, how do you translate that? 0.5 microfarad. Okay, so it'd be 2 over S, right? Okay, very good. So now we go to war with this, and we're not that far away. So basically, we got a 10 over S squared times S over 2S plus 2. So this is 2S plus over S. Denominator is the numerator. So one of these goes away and is equal to 10 over S times 2S plus 2. We extract the 10 and the 2, so we get 10 over S times, excuse me, let's write it again, 2S plus 2, which is equal to 5 over S times S plus 1. So what's the split? Luke? S and S plus 1 in the denominator. What's the split? It's A over S plus B over S plus 1. Everybody, you see that? Everybody agree with that? So now we rewrite it. So it's 10 is equal to A times S plus 1 plus B times S. Let. Yeah, you're right, 5, yeah. Sorry about that. Five is equal to A times S plus 1 plus BS. Let S equals 0. Let S equal minus 1. SF equals 0. 5 is equal to A. If S equals minus 1, 5 is equal to B times minus 1. Or B is equal to minus 5. So now we rewrite it. I of t, and back into the is equal to 5 minus 5e to the minus t over tau, or minus 1. And we're done. That's how that one's done. Any questions about that? Pretty straightforward. Okay, number 15. Now it's a little bit, this is a little more difficult. Why? I did one other thing. I forgot about the sign. So what is this? What is the conversion of this guy? I forgot about this one. You should be able to figure it out. Ten sine 2t. And then I've got 2 up here. And I've got 0.5 over here. And I've got what? So what is my 10 sine 2t? Well, we'll give you the 10. What's the sine 2t? Squared plus 2 squared. Everybody agree with that? Any questions? What's up here? 2. What's over here? 2 over s, right? What is I? Ethan, what's I? I'll give you the v. That's my v.
2
It's plus 2 over s, right? This translates to this, right?
since it's an AC signal, that's
Okay, We don't have an initial condition. So there's no initial condition. So you don't have to worry about you don't have to worry about the VC at zero. There is no VC at zero yet. So how do you do this? The answer is very carefully, right? You got to be very careful how you do this, but you can. Okay. So it's equal to what? 20 over s squared plus 2 squared times s over 2s plus 2. Excuse me, it's over 10s. Yeah, it's 10s. Huh? Yeah, I'm getting there. So it's equal to 10s, because you cancel this and the 2, this is s plus 1. 10s in numerator over s squared plus 2 squared times s plus 1. Now what do you do? You can, but really it's equal to, yeah, you're right. It's pretty straightforward. It's equal to a over s plus 1 plus k over s plus 2j plus k star s minus 2j. Because this becomes this, right? Because if you say s plus 2j times s minus 2j, what do you get? You better get this. Right? Okay, any questions so far? So, what are you going to get? What are you going to find when you get, so now this is 10s is equal to a times s squared plus 4 plus k times s plus 1 times s minus 2j plus k star s plus 1 s plus 2j. And we can forget about the k star. The k star goes away. We don't really have to worry about it. Okay, but we have to worry about the k. All right, so first of all, we let s equal what? Minus 1. This term goes away, and this term goes away, this term stays. 1 plus 4 is 5. Minus 10 is equal to a times 5. A is equal to minus 2. So we got our a term. What about our k term? This gets messy, but you can do it with that calculator. Okay, so what you do is you let s equal minus 2j. And this term goes away, and this term goes away, but this term stays, okay? Everybody follow that? You want this term to stay, so you make it equal to whatever it takes for this to not go away. So you let it equal this plus this is minus 4j. This term goes away. this term goes away. Everybody see that? So now all you have left is what? Minus 2j times 10, or that, which is minus 20j, is equal to, a term goes away, this term goes away, it's k times s plus 1, or 1 minus 2j times minus 4j. K is equal to what? Minus 20j over minus 4j times 1 minus 2j. And that you can put in your calculator and get the answer. Okay? If you got a nice calculator, you can put that in your calculator and you can get the answer immediately in polar format. All right? Everybody follow that? So how do you do that? You put it into complex mode, minus 20i divided by parenthesis minus 4i times parenthesis 1 minus 2i parenthesis. Oops, I gotta do it again. Yes, sir. Did I mess it up here or down here? Where? Down here?
When it's you let S equal minus 2 again, I think where it should be like S equal 2 again.
No, I want it to equal to minus 2j because I want this term to not equal 0. This term, if I let it equal minus 2, this one goes away, this one goes away. This is, if I write it out this way, k times s plus 1 times s minus 2j plus k star times s plus 1 times s plus 2j, I want this term to not go to 0. So I have to say, let s equal minus 2j. This one will go to 0. This one will go to 0. So you have to say let s equal minus 2j to keep this term there. So this is right. That part. Maybe I made another mistake, but anyway. So if you say that, it's 10 times minus 2j or that. So it's minus 20j is equal to blah, 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 all that kind of stuff. So you can, now I had it in the wrong mode, but I'm going to say minus 20i divided by parenthesis minus 4i times parenthesis 1 minus 2i parenthesis equals, I get 1 plus 2i. or it's the square root of 5 at 63.3 degrees. So the final answer is what? So the final answer is I of t is equal to a, which is minus 2 e to the minus t, which is this term, plus 2 times the square root of 5 cosine of 2t, which is the 2, at angle 63 plus, I just want the plus the angle. I don't want the physical, plus 63.3 degrees. That's my final answer. We'll pick up, if anybody questions number 15 or whatever, we can do this one again. I have more of these with a sign in there, but basically, this is just manipulation of turning things around and all that kind of stuff. I can see that it's not going to be the most popular test, I know, but by doing this way, I hope that you can pretty much get it. And if you want it, it's available and it will get you a PE. And that's about the only thing I can say other than